In differential calculus, like we did in the previous class, or we said in the previous class, that it has to do with your ability to differentiate a function. It's actually a change in y with respect to x. We said a lot in our previous class, but Anam told us that the general form of differentiation, that if you have a function y equals to f of x, here what we are saying is that y is a function of x. For instance, I can have that y is equals to x raised to power 3, like we said. So for you to differentiate a function, we said that you are differentiating y with respect to x. So you write dy over dx, which is equals to, now the question is, how do we differentiate a function? Very simple. Use the power to multiply the coefficient, then subtract 1 from the power. So 3 times 1 will give us 3. Then x raised to power 3 minus 1. That is power times coefficient. Then I subtract 1 from the power. So that means that dy over dx is equals to 3x raised to power 3 minus 1 is 2. Basically, that's how to differentiate a function. So for instance, if I have another function, say y is equals to maybe 5x raised to the power of 4, then dy over dx will be equals to, remember the rule, use the power to multiply the coefficient. So 4 times 5 is 20. Then subtract 1 from the power. That will be x raised to the power 4 minus 1. So that dy over dx is equals to 20x raised to the power 4 minus 1 is 3. Okay? So in general, if y is equals to x raised to the power of n, then that means that dy over dx will be equals to n times 1 is n, then x raised to the power n minus 1, that is n minus 1. So that's the general form of differentiation. So these are the things we looked at in our previous class, and we said that for you to successfully differentiate a function, you must use the power to multiply the coefficients, then subtract 1 from the power. For instance, if y is equals to ax raised to power n, then dy over dx is equals to n times a is an, then x raised to power n minus 1, n minus 1. So we did all this in our previous class. Another thing is, if y is equals to, say, x raised to the power of 2, then dy dx is equals to 2 times 1 is 2, then x raised to the power 2 minus 1. So that means that dy over dx is 2x raised to the power 2 minus 1 is 1. Of course, you know you cannot write the 1. So the derivative of x squared is 2x. Meaning that if I have x equals to, y is equals to x, then what is dy over dx? Very simple. Remember that at this point, the power of x is 1, though it is not written, but we all know that 1 is there. So you're now going to say 1 times the coefficient of x is 1. So that will be 1 times 1, which is 1, then x raised to the power 1. Don't forget that 1 that was there initially. Then remember, you must always subtract 1. So dy dx will be equals to 1x raised to the power 1 minus 1 is 0. And we know from the laws of indices that anything raised to the power 0 is 1. So meaning that x raised to the power 0 is 1, which means dy dx is equals to 1 times 1, which is 1. Which means that anytime you differentiate a variable x, the answer must be 1. Okay. If I have something like, say, y is equals to 2, what is dy over dx? To differentiate y, which is equals to 2, this 2 can be written as y equals to 2x raised to the power 0. I introduce x raised to the power 0. Of course, anything raised to the power 0 is 1. 1 times 2 is 2. So it doesn't change anything. So for us to differentiate this, following the normal rule, 0 times 2 is 0. So that means that dy dx is equals to 0 times 2 is 0. Then x raised to the power 0 minus 1. Power times coefficient, then subtract 1 from the power. So it means that dy over dx is equals to, of course, anything multiplied by 0 must give you 0. So in a nutshell, If y is equals to x, dy dx is equals to 1. And if y is equals to 2, dy dx is equals to 0. That is to say that the derivative of a variable is 1 and the derivative of a constant is 0. Take note of those two things. That the derivative of a variable is 1 and the derivative of a constant is 0. So, this actually forms the basis of differential calculus. Now, there are certain functions we are going to be differentiating as far as this course is concerned. And the functions we are going to take time to differentiate are the polynomial function, product function. We're also going to differentiate chain function, quotient function, implicit function, parametric function, logarithm function, exponential function, trigonometric function, and hyperbolic function. So these are the functions we are going to really take our time to differentiate in this particular video as regards this course, Maths 121.